Welcome back to class. Now we want to start solving problems on Surds. Are you there? Now the very aspect we are looking at is problems and solutions. Right? Now we want to look at the aspect of general simplification of Surds. Simplification of Surds, general simplification. That's the basic introduction to Surds problems. Right? Now we are asked to simplify the following Surds. This is root 45, root 98, root 72, root 108, and root 300. What does this mean? It means that we should reduce these values to the least possible. So what do you do? In this aspect, what you do to be able to simplify this aspect of square root, or this aspect of surd, to simplify this aspect of surd, is to look at the number inside the roots. Guys, pay attention to this because the principles are coming one after the others, right? Now, is to look into the roots and see the numbers there. Alright? Now, what you do to the number is to find two numbers that their product will give you 45, and one of those two numbers must be a perfect square. Hope you got that? Yes. In solving this aspect, in simplifying surds, what you do is find two numbers whose products will give you the number inside that square root, and one of those numbers or those factors is a perfect square. And ensure that in some cases that perfect square is the highest perfect square that number attains, because there are some numbers that have more than one perfect square. Yes, they have more than one perfect square. So you will pick the highest of it. Now, I will teach you how you can get this perfect square. Now, the basic way or the simple and the easiest way to have this done is to use the least factors. Are you there? Yes. Is to use lowest common factor method. Are you there? Yes. Is to use the lowest common factor method. How do you use to do that? Now let's pay attention to this. Now we are solving question number 8. We are asked to simplify root 45. What is the answer of root 45? First is to split 45 into two numbers. How do you split 45 into two numbers? Guys, just follow me. This is the easiest way. Pull down 45. Then the least number you will use to start dividing any number on surd is 2, not 1. You don't use 1 here because 1 is a perfect square, so you don't use 1 because 1 does not reduce the size of a number, right? Whether by multiplication or by division, it does not reduce, does not increase, except by addition or subtraction. That's when it has effect on a large number. But outside that, whether multiplication or division, 1 does not have effect on large numbers. Now, so you don't use 1 here, so you start from 2. The least number, you start dividing other numbers with is 2. So when you check this now, this number is not divisible by 2. Is that correct? Yes. So the next number here is 3. So I will now say, okay, can 3 divide 45? Yes. 3 can divide 45. So put down 3. 45 divided by 3 will give us 9. Sorry, 45 divided by 3 would have given us 15. Now 3 times 15 is what? Is 45. But guys, between 3 and 15, none of them is what? A perfect square. Now we move ahead and say, okay, 45 divided by 4. 4 in any number that 2 cannot divide, 4 cannot divide. Then we move to 5. When we use 5 to divide these guys, we are going to have 9. 45 divided by 5 is 9. So 9 times 5 is 45. So now, why for this case I have 3 times 5 as the factors of 45, and here I have 5 times 9 as the factor of 45. As well, 45 is not divisible by 6, it's not divisible by 7, it's not divisible by 8, only by 9, which will also fall back to what this. That means the two major factors that we have now is 3 and 5 that can divide 45 confidently, right? 3 and 5. Sorry, 3 and 5. 3 and 5, which will give us 15 and 9. Now, between this and this, which one should we go for? Of course, 3 is not the perfect square. 15 is not the perfect square. That disqualifies it because the two factors we take, one of them must be a perfect square. Then when I come to this aspect, 5 is not the perfect square, but 9 is a perfect square. That makes this good. One of them must be perfect square. Is that correct? So one of the figures here must be a perfect square. So in as much as in these two factors, one is a perfect square, then we are going with this. And it happens to be that the largest number is the perfect square. So what do we do here? We just come here and replace this by 9 times 5. This is it. Then what you do next is we are going to now use rule number 1 here. Rule number 1 says that you can split this as root 9 times root 5. Guys, hope you are here. It's as simple as this. This is what root 9 root 1, rule number 1 stated. Rule number 1 states that this is exactly the same thing as giving 9 its square root or sharing the square root for the two values or two figures, right? So we have just shared the square root for the two figures. Now 9 is a perfect square. What is the square root of 9, guys? We are going to have 3 times root 5. Then here we are going to be using one of the other rules again, which happens to be, I think, rule number 4, right? That when you have a number outside square root or a number without square root, multiplying a number with square root, that the answer will just become 3 root 5. This is the answer to this very question. Hope this is clear. Yes. Now let's solve the next question. Number B. Number 2. We have root of 98. So we are going to be looking for the product of two numbers. So now, which two numbers will give us this? So the least way, like I said, the easiest way to get the factors, two factors of what? 98 is to start dividing by the least number, which is 2. So if I divide 98 by 2, I'm going to have 49. So this is 2 times 49. And now, guys, please pay attention to this. Like I said, the first, you just take the number divided by the first least number if it is with 2. If 2 cannot divide this number, you move to 3. If 3 cannot divide, you move to 5. Like I said earlier, a number that is not divisible by 2 is also not divisible by what? 4. So you jump 4. Now, in this case, now when we divided 98 by 2, we have 49. That shows that the two factors here are 2 times 49. Now, the next thing you do is to check. 2 is not a perfect square, but 49 is a perfect square. That means this value to be okay for us. Now, why are we going with this? Why are we not trying another way round? The reason why we are not trying another way round is because the highest figure here is the one that is the perfect square. But in assuming this was 4, for instance, now I have 4 times maybe 16, and then I would have doubted that in as much as this biggest number is not a perfect square, it is possible that there is still a perfect square inside this number. Are you there? So for the sake of this question now, we know that the least number here is 2, which is not perfect square, and the one that is perfect square is the largest. Are you there? So in as much as the next number here is the one that is a perfect square, then we are okay. Then what do we do? We just come here and put the perfect square come first, please. Ensure that you allow the perfect square to come first with easy analysis, right? So ensure that the perfect square comes first. So I now have 49 times 2. Now we are still going to be using rule number 1 here, which says I can share the square root for the two figures. And now 49 is a perfect square. 49, the square root of 49, guys, is 7, which shows that 7 times 7 is 49. So I therefore have 7 times root 2. Finally, 7 times root 2. They are not of the same class, so I'm going to have this as root 7 root 2. This is the answer to this very question, 7 root 2. Like I said, a number inside square root cannot multiply a number without square root. So all you do is to what? Have this as the factor or the coefficient of the square root. Now, if this is taken, I know you can solve the other numbers that we have there, but let's go as we solve these numbers together. Now, we have C, and we're told that we have the square root of 72 is equal to the square root of two numbers. So we are going to find two factors such that their product will give us 72. Why are we doing this? We already know that 72 in itself is not a perfect square. But we believe that there are two factors that will give us 72, and one of those factors must be a perfect square. And that's the reason why we are trying to do this try and error method, right? Now, so how do we go about this? We put down 72, now divided by the least number, which is 2. Of course, 2 can divide 72 now. 72 divided by 2, we are going to have this as 36. That shows that the factor of 72 here is 2 times 36. Now, 2 is not a perfect square, but 36 is a perfect square. Then we go with this. But as the largest value here is the perfect square, there is no need to go and use it. Of course, 72 is divisible by 3, which will have given us 24. And now 24 times 3 would have given us 72, but neither of this or this is a perfect square. Like I can come to 4, come to 5, come to 6, just like that. But how do you know when to stop? That's why I'm explaining this. A point where the highest value is the perfect square, or the least you can have, right? So this is what we have. Then the next we have is to now put this as 36 by 2. It's as simple as this, guys. 36 by 2. 36 by 2. Now, guys, we are going to use rule number 1 here, which says that we can share the square root for both 36 and 2. So we have it. Of course, we know that 36 is the perfect square, which is 6 times 6, 36. So the square root of 36 is 6. Then we have 2 now. 6 times root 2 would have applied rule number 4, and this would have given us 6 root 2. Please don't make the mistake of having root 12. If you say that this is root 12, you are very, very wrong. Now we have D. The square root of 108 is equal to the square root of 2 factors. It's as simple as this. Now what do? I put down 108 divided by, of course 108 is divisible by 2, right? Yes. So when we divide 108 by 2, we are going to have 54. That means this is 2 times 54. And now, this is not a perfect square. This also is not a perfect square. You see? Then we move to 3. Neither of this value is a perfect square. Now we move to 108, also divisible by the next factor is 3. And when we divide 108 by 3, of course 108 is divisible by 3. Yes. So when we divide 108 by 3, I think we're going to have 36. Yes. 108 divided by 3 is 36. That shows that 3 times 36 is equal to what? 108. Then we also check also here whether any of these two values is a perfect square. Now 3 is not a perfect square, but 36 is a perfect square. Then we go with this, guys. Hope you understand the concept of what we are doing here. It's very simple. All you need to do is understand rules and regulations. The 2 factors, one must be a perfect square. Alright? So you start dividing with 2, 3, 4, 5. Just start from the least number, and the least number, like I said, is 2. So you start dividing from 2. If the number is not divisible by 2, move to 3. If it's not divisible by 3, just like that. Till you get the factor of that number, one of the factors of that number that will give you the second number after you might have divided the number by one of the factors you get to know. Alright? Now, at this point, we already agreed that in as much as one of these values is the perfect square, then we go with this. So this will have given us 36 times 3. Like I said, pick the perfect square first. Let the perfect square come first. So the next thing we do here is to apply rule number 1, which says that we can share this square root for these 2 figures. And now, what is the square root of 36? Which is 6 times 6. So square root of 36 is 6 times root 3. It's as simple as this, guys. Then the next thing we are quickly going to do, guys, is 6 times root 3. We are going to have 6 root 3. This is not root 18. Because if you have it as root 6 times 3 and you have it as root 18, guys, you are wrong. Why? A number with square root cannot multiply a number without square root. This is the principle. Now, finally, we have E. We are given that the root of what? 300 is equal to the square root of the product of 2 numbers. Now, what are these numbers? So first is to put down 300. Now, 300 is divisible by 2, and we are going to have 150. Automatically, this will have given us 2 times 150. But 2 is not a perfect square, and 150 is not a perfect square. This is what will make us to go again and search for another option. Having made that when we just divided 300 by 2, and we have these 2 factors, and one of them is a perfect square, there is no need to go hence further, right? There is no need to progress to dividing the number by 3. No need. But now we need to start dividing this number by other factors because we have not gotten 2 factors whereby 1 is a perfect square. That is the reason why we want to take a step further. Now we will take 300, and now the next number is 3. When we divide 300 by 3, we are going to have 100. Then this is equivalent to what? 3 times 100. Now 3 is not the perfect square, but 100 is a perfect square. So in as much as 100 is a perfect square, therefore we are going to go with these guys. Now the next thing we do is to quickly what? Split the what? The numbers. And to split the numbers, the rule number 1 states that we can share the square root for the two values. Then we have root of 100 times the root of 3. Now 100, the square root of 100 is 10. Guys, 10 times 10 is 100. Then this will have given us 10 times root 3. And this will have given us 10 times root 3, root 4 is applied. We have 10 root 3. This is not root 30 because a number with square root cannot multiply another number without square root. They can only become coefficients of each other. Hope this is taken. This is the first set of questions that you can see in Surds. So operations in Surds is what we are dealing with right now. We have looked at the first aspect of Surds. Now we want to look at the second aspect of Surds. Alright? I'll see you in the next class. Look at this description below to find the link